In this video, we will discuss the inferences, such as hypothesis testing of the parameter estimates in simple regression. Once we get the estimate for the linear regression model parameters, one important test is to conduct a test of the hypothesis to see if the slope of the regression line is different from 0. If we find that the slope is different from 0, then we can conclude that using the regression equation adds to our ability to predict the dependent variables based on the independent variable. The test is equivalent to the test for the correlation coefficient. We use beta to represent the population slope. So the null hypothesis is whether beta sub 1 equals 0, assuming there's no linear relationship between the dependent and the independent variables. If we cannot reject the null hypothesis, then we do not have sufficient evidence to conclude that there's linear relationship between the two variables. We can use t-test for the population slope in the obtained linear regression model. When testing the null hypothesis about the slope, the test statistic is with n-2 degrees of freedom. The test statistic is given by t-stat equals b sub 1 minus beta sub 1 over capital S sub b sub 1. Well, b sub 1 is the regression slope coefficient. Beta sub 1 is the hypothesized slope. Capital S sub b1 is the standard error of the slope. And capital S sub b sub 1 is equal to capital S sub yx over square root of ssx, which is equal to capital S sub yx over square root of summation of parentheses x sub I minus x bar parentheses squared. Obviously, the computation of standard error of the slope look a bit scary too. The good news is that we can rely on the software such as Excel for some help. For example, in the house price case, we have obtained the linear regression model house price equal to 98.25 plus 0.1098 square feet. We learned that the slope of this model is 0.1098. But are we confident that there's a significant linear relationship between the square footage of the house and its sales price? To answer this question, we have a null hypothesis. Beta sub 1 equals 0 by using t-test. From the Excel output, we know that the estimate of the slope is 0.109777. The standard error of the slope is 0.03297. So using the t-statistic equation, we have t-stat equal to b sub 1 minus beta sub 1 over capital S sub b sub 1 equals to 0.10977 minus 0 over 0.03297 equals to 3.32938, which is exactly the same as shown in this table from Excel. Assuming a level of significance alpha equal to 0.05, the degrees of freedom is n minus 2 equals to 10 minus 2 equal to 8. Looking up the t-table, we can identify the critical values of the rejection region are negative 2.3 and positive 2.3. Given that t-stat is equal to 3.329, our decision is to reject the null hypothesis. In conclusion, we have sufficient evidence that there exists a linear relationship between the dependent and independent variables. In other words, there's sufficient evidence that square footage affect house price. From the perspective of p-value test, we find that the p-value for the t-test is 0.01039, which is smaller than 0.05, the level of significance. So our decision is to reject null hypothesis beta sub 1 equal to 0 and conclude that the relationship between x and y is significant. For simple linear regression with only one independent variable, we have one equivalent test called f-test. In general, an f-test in regression compares the fit of different linear models. Unlike t-tests that can assess only one regression coefficient at a time, the f-test can assess multiple coefficients simultaneously. In other words, f-test is for the entire model, even if there are multiple independent variables in multiple regression. So in f-test, the null hypothesis is the fit of the intercept-only model and our model are equal. The alternative hypothesis is the fit of the intercept-only model is significantly reduced compared to our model. In simple regression, f statistic is given by MSR over MSE. Well, MSR equals SSR over 1 equal to SSR. MSE is equal to SSE over n minus 2. Based on the Excel output, we can obtain the MSR and MSE values from the second table, which are 18,934 and 1,708, respectively. Plugging the values into the f-stat, we have f-stat equals MSR over MC equals 18,934 over 1,708 equals 11.08, which is the same as shown inside the table too. The p-value for the f-test is given by 0.01039, which is the same as that in the t-test. So we obtain the same conclusion because we have only one independent variable. When there are multiple independent variables, the p-value for the f-test is usually different from that of any specific t-test. In forming the decision rule, we can check the f-table for the critical value. Note that the f-table is not required in this course. Given that the degrees of freedom, we obtained the critical values of f equals to 5.32 based on 0.05 level of significance. We obtained the f-test statistic from the previous slides, which is 11.08 and larger than the critical value 5.32. Therefore, we reject the null hypothesis and conclude that there's sufficient evidence for the linear relationship. Based on the above analysis, we can also set up the confidence interval for the slope. which is given by b sub 1 plus minus t sub alpha over 2 times capital S sub b sub 1. Given that the slope b sub 1 and the standard error of estimate value capital S sub b sub 1, the t statistics are all provided by the table. Theoretically, we can compute for the confidence interval based on these values. Of course, Excel has also provided such confidence interval information for the 0.05 level of significance. At 95% level of confidence, the confidence interval for the slope is 0.03374 to 0.18580. We can also draw additional information from the confidence interval. For example, given that the unit of the house price variable is $1,000, we are 95% confidence that the average impact on sales price is between $33.74 and $185.8 per square foot of house size. In addition, usual is not included inside the confidence interval. So we are 95% confident that there's sufficient evidence that house size affects selling price. So based on the Excel output, we can use multiple approaches to verify that whether we are 95% confident that there's sufficient evidence that the linear relationship is over there. In summary, in this video, we have learned how to conduct the t-test, f-test, and their p-values, and the confidence interval estimate based on the Excel output. There are two ways to do that. One is using some information from the Excel output to compute those test statistics. And of course, another easy way is to find those statistics directly from the Excel tables. Nevertheless, you can use them together to verify whether there exists significant linear relationship between the dependent and the independent variables.